Hello everyone, this is Miss Brodie-Willey here today, and today I'm going to be talking to you about the pH scale. We're doing our lesson on Nearpod today, so if you wanted to, you could follow along and go to nearpod.com, go to the student login, and type in this code. So you're probably wondering what the pH scale is. Well, the pH scale is a measurement of a liquid's level of alkalinity, or basicity, or acidity. Alright, so what's an acid, a base, and a neutral? This is going to be very, very important in order for you to understand the pH scale. Alright, so a neutral liquid has a pH that is exactly in the middle of the scale at 7. So right here at 7, where distilled water is, you know that the liquid is neutral if the pH is 7. An acid has a pH below 7, so anything below 7 would be considered an acidic liquid. And a base has a pH above 7. So, as you can see, all these liquids here above 7 would be considered basic. Now today, we're actually going to be testing different liquids to see whether they are acid, base, or neutral using a PhET simulator. Now during the course of the simulation, I'm going to ask you to make a hypothesis, record observations, and reflect on your observations and how they compare to your hypothesis. Now, some of you may or may not know what a hypothesis is, so let me explain that. A hypothesis is something you think to be true that can be tested and proven to be true or false. So today we're going to act like scientists and we're going to test to see whether our hypothesis about each liquid is going to be true or false. Now while we are doing this PhET simulation, I'm asking you to take out a sheet of paper and for each liquid write the name of the liquid color, your hypothesis as to whether or not it will be acid, base, or neutral, and include what you think the pH around whether it will be acid, base, or neutral when we add water to it. And after we do the testing, make sure to reflect on how your hypothesis compares to what actually happened. Alright, so I'm going to choose a test liquid so I can show you exactly how the simulation works. Alright, so we're going to use milk. Now, for this simulation here, you can move around the dropper. It doesn't really matter, you can keep it in the same place, but I'm going to ask you to fill up your beaker here with 1/2 liter of liquid every time. Alright, once you fill up your beaker to 1/2, then you are going to drag this scanner over here to where the liquid is, and it will test the pH. Over here on the left, you'll see the pH scale, and milk's pH is 6.5. And since it is under 7, you will know that the milk is slightly acidic. So milk would be considered an acid. Once you finish testing each of your liquids, you add a little bit of water. You can add up to 1 liter, and then test it. And now you see the pH is at 6.68, so the pH went up. So it becomes more basic when you add water to it. Now we can drain it. And between each of your liquids, just make sure to drain your beaker so it's fresh. Alright, I'm going to try a few more examples with you before I let you go ahead and test on your own. Alright, so how about we do hand soap? Alright. Fill it up to the 1/2 liter line. drag over your scanner, and over to the left you'll see that the pH is 10, and since it is above 7, you know that the liquid is a base, or it is more basic. Now add some water, and as you can see, as I'm adding water, the pH is decreasing or going down, and it's becoming more acidic. Alright, make sure to drain your beaker. And I'm going to do one more test with you. How about we do soda? Alright. 1/2 liter one more time. Alright. Drag over your scanner. You see the pH is 2.5. Since the pH is under 7, you know that it's acidic. Now add water. And as I'm adding water, you can see that the pH is increasing and it's becoming more basic. Now drain your beaker. And once you're done draining your beaker, I'm going to ask that you test 3 more liquids on your own. Spit, battery acid, and chicken soup. And once you are done, you can press play to see the results. You can pause the video so you give yourself time to test it out on your own. Alright, now that you've given yourself time to test it out, let's go ahead and go over it to make sure our results are the same. Okay. So as you can see, spit has a pH of 7.4, which is just about neutral. Let's see if we can add water and see if it'll come close to neutral. Well, as you can see, it's pretty close to neutral. It's 7.21. I'm pretty sure that if we were able to add more water that we could get it to neutral, but we aren't able to do that. So it's as close to neutral as we're gonna get. Let's see. Okay. We're gonna test battery acid next. Drag over your scanner. As you can see, the pH is 1 exactly, so it's pretty acidic because it's below 7. Let's add some water. As we add water, the pH increases and it becomes more basic. Drag this away, clear our beaker. Alright, now let's test our last one. Chicken soup. Let's drag over the scanner. And as you can see, the pH is 5.8. So that's slightly acidic. Add water. And as you add water, you can see that the pH is increasing or becoming more basic. Drain it. So as you can see, out of all these test liquids here, we haven't really found anything neutral, but filling this beaker with water, you can see that it's exactly 7, or it's neutral. So out of all of these liquids, water is the only one that is completely, exactly neutral. And if you want, you can take a little bit more time to play around with the simulator and test the other ones that we didn't test in our lab. But once you're done, we can move on with the lesson. Now take the time to reflect on all of your observations and whether or not you thought each liquid was acid, base, or neutral, and how that compares to what actually happened. Now, once you are done doing that and finishing your reflections, we will assess our knowledge using plickers.